We're back from our vacation, and today we'll be making potassium cyanate. To do this reaction you'll need a small 30 ml porcelain crucible like this one. First measure out 11.7 grams of urea. We're using urea here in a 2.2 molar ratio, which apparently gives a good yield of fairly pure product. Now for our second reactant. Weigh out 5 grams of solid potassium hydroxide. We didn't crush it up but just left it in the flame form like this. Add the potassium hydroxide to the solid urea and mix together roughly. And then fill the crucible with the mixture. Pack it in tightly, and when full it should look like this. Set up the crucible with a clamp or tripod to hold it in place so that strong heat can be applied. And then start to heat it gently at first. We're using our dedicated lab kitchen burner, but please don't do this in your regular food kitchen. Very soon the urea will melt and the potassium hydroxide also seems to go into solution to form a clear liquid. And with a bit of extra heating the mixture then starts to bubble as the urea decomposes, and ammonia gas is produced. Go easy with the heating and remove from the flame if you need to in order to avoid the mixture boiling over. Slowly the contents of the crucible will dry out and form an off-white colored solid. Do remember to use lots of ventilation throughout this reaction because the ammonia gas is quite irritating and toxic if inhaled. You can see we've now got a bubbly white solid remaining. Now apply strong heat to the crucible and get it up to over 300 degrees C in order to melt the solid. Ammonia gas will continue to be produced. Eventually the solid will completely melt and give off small bubbles of ammonia gas as you can see here. Once this bubbling dies down then the reaction is complete. The whole process takes around 20 minutes to complete. Allow the solid to cool inside the crucible. And once cool to room temperature use a metal rod to push it out. The product forms a cake in the bottom but it's fairly easy to get it out. Here we go. 6.5 grams of a very crude potassium cyanate product. This also contains some residual potassium hydroxide, potassium carbonate, and some urea degradation products. Add 15 ml of hot water to the solid product in a beaker. And then stir to break up and dissolve. Not everything dissolves at this point. You will end up with a mixture with a white solid precipitate in it like this. Test the pH of the mixture. As you can see it's strongly alkaline. We'll use the weak acid to get the pH back to around neutral so that any potassium carbonate and hydroxide are neutralized. So here's a small amount of glacial acetic acid. And we'll add a few drops of this to start with. Stir it up and let's test the pH again. Now at about 10. Add a little bit more glacial acetic acid and stir it up well. The pH is now at 8, which is where we want to be. Be careful adding the acetic acid because if you add too much to a warm solution you'll start to hydrolyze the cyanate back to ammonia. So now we set up for filtration. Since there's not much liquid we'll just gravity filter this. And if you don't know already, learn how to make a fluted filter paper like this. It's much more efficient and will save you a lot of time. Warm the mixture up to between 40 and 50 degrees C so that the cyanate is nicely soluble. And then filter. This is fairly rapid, but use a spatula to disturb the solid in the paper occasionally and it will go faster. Once done, there will be a bit of solid left in the filter, so add a further 5 to 10 ml of water and stir it up well. Only a small amount of insoluble solid should be left behind. Now take a larger beaker and measure out around 100 ml of absolute ethanol. We've used slightly more as you can see, but using less will result in a better yield. We're now going to add our filtrate on the right to the ethanol. The water will form a solution in the ethanol and the change in solvent conditions will cause our product to precipitate out. You can see a white gelatinous solid building up in the beaker. Note that we also did a little experiment and took some acetone in a beaker here and added some of the filtrate dropwise to this instead of the ethanol. It seems to work just as well, and may even be better if the product is less soluble in acetone than ethanol, but we couldn't find any figures on this. Here's our ethanol and filtrate mixture. We chilled this down to fridge temperature in order to make the product less soluble in the ethanol, and then set up for vacuum filtration. We allowed the product to dry a bit on the pump, and then washed with a small amount of cold ethanol. The product is hard to get dry, so once it formed a paste we took it out of the filter and then oven dried it at a low temperature of 100 degrees for an hour or so. The paste reduces in volume considerably as it dries out. Here's the final product. 3.5 grams of potassium cyanate corresponding to a 48% yield on starting potassium hydroxide. The references we used for this reaction quoted an 80% yield, so this is a bit disappointing. It's possible that the product is more soluble in ethanol than we thought and we lost a bit this way. Okay, we know what you're thinking already. You're going to ask, is it possible to convert an alkali cyanate salt into the corresponding cyanide? Well, we don't know because we've never tried, but we're going to try now and see if the chemistry urban legend is true. With the cyanate back in the crucible, we weighed out 0.4 grams of very fine medicinal charcoal and added this to the cyanate. We mixed this thoroughly and then placed it back on the gas flame again to try to melt the mixture. We're not sure what temperature the reaction occurs at, but we'll only get up to around 500 degrees C here. You can see the solid melted and then began to bubble. As the temperature rose, the entire mass melted and bubbled, and a small amount of ammonia was given off. We continued the heating for about 15 minutes until the bubbling died down and the bottom of the crucible was red hot, as you can see. Then we allowed the mixture to cool down. You can see some white solid which has crystallized in the mixture. So first we'll dissolve the solid in water and then filter off the excess charcoal. We added about 10 ml of water. The solid was extremely soluble in water, dissolving rapidly. This is our first sign that maybe we've got something. As before, we set up for gravity filtration and filtered the mixture. This was fairly rapid, leaving excess charcoal in the filtered paper and a nice clear colorless filtrate solution. So let's do some qualitative tests in order to see if this mixture contains any free cyanide ions in solution. We'll start with the reaction we did in our previous video on cyanides. This is a warm saturated copper sulfate solution. On adding the filtrate, we're getting a brown colored precipitate. This is the right color, but there's no sign of any cyanogen gas as there would be if the filtrate was a fairly strong cyanide solution. So let's try the classic test for cyanide salts, the Prussian blue test. This is a solution of iron 2 sulfate and iron 3 chloride. Now let's add some of the filtrate. An intense deep dark blue colored precipitate is formed. Let's add some water so you can see how intense this color is. We can even pour this into a beaker of water and the blue color is still quite obvious. So this is proof the filtrate contains inorganic cyanide, and a reasonable amount of it. We don't know how much, and whether there are byproducts or unreacted cyanate in the solution, so it's probably not a great way to make cyanide salts for synthetic purposes. But it proves that it's possible, starting with urea, potassium hydroxide and charcoal, to make a small amount of inorganic cyanide. Scary.